Hello, this time around we are going to start working on the networking layer, doing in some integration tests from this point of view. So the plan is to implement a socket network layer. So we're going to use a socket server, and that's because they're more interesting than IMI, but it could be either one. I think maybe IMI is even easier to do integration tests with, because sockets we do have to do a little bit of extra work. I'll get back to that. We're going to use tests again to develop the functionality, and we're going to keep it as close to the real thing as possible, but not completely real, because there are some things that the basic unit tests don't deal with very well, and those are sockets and threads. So threads means you're running code in parallel and asynchronous, and that's just difficult to manage with unit tests. Maybe the test is finished before the thread is finished, and it's just inconvenient and difficult, and I don't really know a way around it. And sockets, I mean, we could instantiate a server socket and client socket and connect to it, but that seems like more work than is necessary. We could probably do it, but I'm going to isolate these two parts on the server, so they will be such a tiny detail that it's fair to not test them. That's the idea. We are going with the protocol of request response, so the client will send a request, right, and then get a response back, always, whether it's just whatever you wanted went okay, or here's the stuff you requested. So the client is going to make a connection to the server handles this connection in a new thread, so we don't block for other clients. This is pretty standard, and I have other videos showing how to do this, and this is what you're being taught in SDJ2. Once the connection is established and managing this new thread, the client will send a request object, and the server will then manage that, handle it somehow, and it will send a response object back in, and then the connections are closed. So we don't maintain a continuous connection like if you want to do a chat system, or you want the client to get some kind of live updates pushed from the server. Then you need to have a continuous open connection between the client and the server. We don't do that. We open connections and make a request, get a response, close the connections again. Next time the client does something, it's the same protocol over again. All right, so this is our current status. I have tests, and we can test our entire system through the service interfaces, down through the service implementations, and I use the DAO interfaces, and then I have those actual real PostgreSQL, still capital S. I'll fix that someday, eventually, perhaps, maybe. And they're going to use my database, which is a clone or a mirror of the production database, but this is the one that I use for tests. So all the tables are cleared out before each of my unit tests. And this time around, we want to put some networking layer on and use our test from here. So how do we organize this network layer? Again, you have seen in other videos, and I assume you watched them, and in class it has been taught a way to do this. So let's just refresh it, because we do have to make some minor modifications to make it easier to test. So we focus on the network layer. What are we going to structure here? What are we going to do? And well, usually you have these parts. There's a socket client. So this is the one running on the client side. It connects to the socket server, my program running here. This is just a while loop with a server socket that accepts connections. And whenever a client connects, we take that client instance and we hand it over to a server socket handler, whatever you call it, and then run this in a separate thread. Then my socket server is ready to accept the next client and hand that over into a separate thread, and then handle client. So this one accepts connections and starts the handlers here. The server socket handler usually get the request sent by the client, they will then figure out what the client wants to do and call the relevant methods on the service interfaces. So if the client wants to update a username, we will send a request that reflects that, and this one will figure out that's what we want to do and call the user service dot update username. And this one may throw an exception, or it may just return voids, or it may return something. In either case, we always send a response back to the client, giving some indication of did it go well, was it a success, did some error occur, in which case you get an error message to show to the user. So this is the classic approach that you have seen in class and in other videos. And in here you will have usually you will have an if statement or a switch statement switching on the request type. So there will maybe be a string in here, and then you will say if request type equals update username, call one method, else if request type equals so on. And we're going to do something similar. Alright, so this is the classic approach. Let's go with the slightly updated one with a half-hearted in-between animation here. We still have a socket client, whatever it is. I don't care about the client right now, I just make my server available. So this one remains the same, more or less. Now I have renamed this to call it socket request receiver, and it uses a request handler, and this one contacts the service interfaces. So I have split my server socket handler into two parts. So it goes like this: client connects, the server is untouched compared to the previous example. It creates a new thread and runs this socket request receiver instance in that thread. Whenever a socket client here sends some request object, this one will do absolutely nothing other than just handing that request object over to the request handler. And this one is then responsible for figuring out which service interface methods to call. So the switch or if statement I talked about before has been moved from up here to down here. That's the idea. So now we can call methods on the relevant services, and again return stuff back to the socket client to either indicate success or failure, or the requested object is sent back, or whatever we need. So splitting this class into two, well, the socket server handler or server socket handler, whatever you call it, splitting it into two means that I have isolated my socket and thread stuff in here, and I can use my tests against this one. This here is 10 lines of code, and once it's set up, it will probably not really change for the rest of the system. This here is roughly the same. It just receives a request object, hands it over, get a response back, and send that back again. So it does almost nothing and is super simple and hardly worth testing. So this is where the actual stuff happens. I mean, I can do one test for this, one or two tests, and if that works, it's a fair assumption that all kinds of request response interaction works for this one. So this is the one we want to work against. So I sort of have two layers within my network layer. The initial stuff up here, which hands over to the actual whatever we need to handle, and we do the lower part. That's the idea. And further, I will start out with the classic approach just to show that again, because I need most of it, and then I will do that refactoring to the slightly different approach, previous slide, and then we will start implementing some features through my tests. And we will continue with the create user and update username. Those two I've done before, so I have most of that in place, so we can just see how that works up here, the network stuff. But then I want to try and move on to something that I have nothing of, so you can sort of see how we do you might call it an acceptance test and develop the system through, I can write an initial test that will test the entire system initially, and then obviously that will fail because I have nothing in any of the layers, but then we can do minor test-driven development for each of the layers as we have done so far, and eventually, hopefully, that initial success acceptance test will succeed. Now, I don't know how much time this will take, so maybe the two last ones will be in a new video, but the idea is that I have my entire server stack here of layers, and we use my test to run everything here and just verify that my server works exactly as we want it to. And then the last two here, I do have some create task, I think, in the service layer, but nothing with the data access up layer and nothing for the network layer. So this one will be almost a full implementation, and this update remaining estimate on a task, I have nothing implemented of this, so that will be a full implementation, meaning that we go through all the layers. And I think the approach will be first the service layer with the two interfaces, then add the data stuff, and then we can work against the entire system. So I still do it in steps. I think that's the idea, but we'll see when we get to that point. So let's get to it and cross your fingers. I haven't tried this before. Let's see how it goes. I just have an idea in my head. So, IntelliJ, where are you? There we go. Alright, so I am sort of losing track of my tests here. I don't know if I'm super happy with the way they are organized. I have service tests, database integration test, and server integration tests. I mean, maybe I want to call this server acceptance tests, because that's basically running the entire system through the tests. So not just only server stuff, but here the tests in here are supposed to do everything in the right way. And I learned something new, which should have been obvious, but I mean, whenever I run something, it will just run the tests in a single class. And I mean, you don't want to go through all of the classes and run it, so you can just right click here and say run all tests. So whenever you do something just before you commit, you just run all your tests, and you can see all is green. That's pretty good. I could actually also say run test in a specific package. So by doing it here, I'm also running all of the client tests. Maybe I only want the server test. So okay, acceptance test. Let's see if you can server acceptance tests for user. Let's try to keep some kind of organization. And I probably need an before each, just to set stuff up. And this will, I don't really have the stuff that I need to set up, so we'll do that along the way. And we just say set up entire system. And I want to do a separate one before each. Public void setup, clear database. There we go, because I need to clear my data just like we did in the other tests here. I have this one here, delete from user. Right. Okay, we will fix this later. And the entire system, well, I'm going to need so each of the layers, let's do a Postgres, what's it called? I need the data access object. User, Postgres DAO, and it's a user DAO, user DAO, and new, like this. And if I cannot create this, because what could go wrong? Well, yeah, it's okay to throw this, I think, because if I cannot create this instance, then there's nothing in my system. I can't really recover from this exception. This one might throw an exception if I have a collision in username. Now I know how to test that in the business logic layer, but still, maybe there's some other way to create a user from a different path and someone forgets to check that logic. In which case, it's just a validation error, basically saying you cannot create a user with a duplicate username, so it's okay to catch the SQL and then throw an exception that we can manage. But up here, I think my system should just fail and then figure out what can we do to fix this. We need developers to fix this. The user can actually correct this by just picking different username. So that's the difference. That means we can just throw that. And this one needs connection string, so I gotta steal that from over here. Just copy the entire line. Right, and then I need my I don't know if I need this as a field variable, in which case at some point we will just fix it if I do. And then I need my user service this one, new, yeah, and it takes the user DAO. So I'm constructing my system from the bottom up, basically, in the flipped around. And then I need a socket server. I don't have that yet. Socket server equals new socket server. No, I don't need that. That's not what I wanted. I wanted my request handler. Request handler, new request handler. And this one should know about my user service. Probably at some point I'm going to need other services in here, so we'll see about that. And I need to create a class for this one. That goes into the network. Java class request handler. Okay. And then I can import it. And then I can create a constructor. And then we can assign this to, no, we don't want to do anything in here. Yeah. Clear database will fix that. So request handler, that's the one, yeah, I want to edit. That's the one I actually need to call methods on, as we saw, oh, not in data grip. Here, right, my request handler, my test goes against this one. I'll do these in a moment, the purple area, but I just want to write the acceptance test first. Request handler, yeah, and then we say test, and we say public void should insert user, and we go range act assert. So first I need my request handler here. Oh. Okay, what actually happens? The request handler handles an object. So let's call that request object. And does it return anything? I think I should have returned that ID I talked about at some point, but we'll fix that later on. Okay, so we just tell the request handler, that's this part here, request handler gets the request object handed over, and it should now contact the service interface. And it has a service interface, so it can contact that. The assert is that I want to see if there's actually anything in the database. And at this point I don't have that ID, because that's created in the user service symbol, right? This one creates the ID here, So I did talk about sometimes in your client side you would request to create something new, and then maybe you want to open a new view that shows that new stuff that you created, which requires you to get the ID so you can actually request it. So we are going to, this returns an object of something, response object. We're going to fix that. User service create should return a UID, and this one returns a UID, and this one ID can then be returned. Return ID. Okay. So minor fix. Let's just, now I did some refactoring and changed stuff. Maybe I broke things. Right? We gotta follow protocol. Okay, nothing broke. Nothing expected that ID, so no one cares that I'm now returning it, so that's pretty easy. Okay, back to this one. I get the response object back again, and we say created ID equals, should be able to cast this, response object response. Yeah, so now I have the ID, the result of creating something, and we might just say, I mean, I could write the raw SQL and fetch something, but I do know that this method works here on the user DAO. So let's just be lazy. I think we will just call it an interface like that. Assert find created ID, and what can I actually check on this one? Assert not null, and I need all my assert stuff again, all of these tests. Assert not null user. Arrange, do I need to arrange anything? I sort of have that up here. There's nothing to do beforehand, is there? Well, I do have to create the request object. Request object equals new request object, and it takes a command, request type, and it takes an object. Let's call it payload. All right, so the request type is a string. Request type equals, and we say, what are we doing? I want to try this. User create, and payload is, what do I need here? I need to send some kind of information so that we can create a user from that. And what does the user service interface actually request? To create something, I need a username and password. So I need an object to contain this. I don't want to send a user object from the client because that has other stuff, an ID, for example, which I don't think should be set on the client side. So I want to just send these two in a different object, and we call it create user request. CUR new create user request with a username and that password like that. That should be okay. And That's actually the payload. There we go. So a bunch of stuff that doesn't work. Let's see, where do we start? Maybe we should have started by this, one step at a time. Okay, it doesn't matter. I need to create user request, and this is the object that we're going to send from the client, and it's going to go over here to the server. So it should be somewhere that the client and the server knows about, and we're doing a Java client. So I'm going to create a new module and could just call it shared. So everything that the client and server needs to both know about, I put into this one. That's the easy approach. And here we say package request objects, and I create a class for the create user request. Yeah. So I need to make the test know about the shared. So we go module info. Maybe am I lucky enough that it add dependency? Yeah, that was easy. And then I need a constructor, a string username and a string password, and I want to create a field. I want to create a field for these two. Yeah. Okay, so that works for now. Then we need the request object. So this one contains both the payload and the request type. So this one goes in here as well. So it's sort of like a carrier object. Request object like that. And I'm sending it over the network, so it has to implement serializable. Yeah, and I need that in the other one as well. Okay, and this one can now be imported, but then we need a constructor, string request type. This is going to be an object of payload, and can I auto generate stuff here somehow? Insert. I wanted to have both of them. I can only do one at a time. Yeah. Now, if anyone is familiar with records, these type of objects are pretty good for records. Maybe I'll get back to that at some point. Okay, so that's one step closer. Then we just need to have a handle method here. Create, and it handles an object and returns an object. And here we handle a request object. And that one. And why do I have to do like this? That's because my server now needs to know about this shared as well. Let's do that. Maybe I can just do add dependency. Yeah. So my server knows about the shared, so we can reference the request object. Yeah. Okay. That's a lot of stuff, but now everything compiles. If I run it, then obviously I have a red test, but I am okay with that for now. Use ID not found. So this one didn't actually do anything. Obviously returns null, so that's okay. So next up, I think we will do the purple stuff here, just to show you how I get from that socket thing to the request handler. That's the idea. Let's go. Okay, first I think I want to do one more thing. To do insert user failure scenario. So this is my success scenario for inserting a user, and I need to test that what happens when it fails. But I don't think I need to create all kinds of different success and test scenarios, because that's just testing the business logic. I mean, I could create requests for different passwords, and sometimes it would fail because the password is not valid and so on. But I have tested that logic, so if one thing works and one thing fails, then it's fair to assume that it's well covered. So that's the idea behind creating a lot of tests for your business logic, and then we can scale down the number of tests with just maybe we only need one success and one failure, just to make sure that those parts work. But I'll write this one afterwards, later on. Let's just clear this out. So we're doing the server socket, the actual server, just to put that into context. So we just call it socket server. And it has a public void start server. And here we create a socket, a server socket, right, from java.net. New server socket, it takes an IP, and I think usually 2910 in honor of my colleague. Yeah, I edit. And if this fails, then I don't want to catch and do anything else, because then I cannot recover. Then we have that while true. So we say server socket. Now I want to accept a connection from a client, which gives me a socket instance. I just call it client. And then what we do is thread, no, we say, let's call it socket server socket handler. That's what my initial idea was. Server socket handler equals new server socket handler, and it takes the client, and then we start a thread t equals new thread with the handler and t dot start. Alright, so this is the super basic socket server. I mean, I did say 10 lines, which is sort of close the actual code, 7 to 17. So we really don't need much initially. Maybe a bit later. I need this one. Let's just create the class. Create class. Yeah. It's okay. Takes a client and it implements runnable. And then we have the run method. There we go. So this part now, this is now done. It's responsible for accepting client connections and handing them over to that new thread, and then go back up and accept a new client connection. Easy peasy. This one here would create, so we say this client equals client, just assign that to a field variable. Yeah, and down here we say client get no, I need to create a new object input stream with the client get input stream, yeah, and in from client, and this one might throw okay, I cannot throw an exception here, so because this method is from an interface I don't control, maybe we put it into the constructor. Just do this, because then we can just throw it. I mean, if I cannot create this, then something fails. But it's just for one client, and I mean, that should not fail the entire server, so we'll do it down here. And okay, we'll work our way through. I also need an object output stream out to client, new object output stream, clients output stream, like that. Yeah. And then we say, but I need that later on. We say in from client, read object, and I know this is going to be a request object, because that's what the protocol says. You have to we might not find the class because the client may have sent something that we don't know about in theory, but I know that's not going to happen. The request object, and then what we would normally do is, request object switch on request object dot get request type, and that returns a string, return request type, like that. And then we can say a case, what was it, user.create. We want to do something, and then we want to break, then case user update password, for example, and so on. And eventually I would get some response from either of these, or I would send it back again. So the point is, now I have my thread stuff. I have this is running in a thread. I am getting stuff from the client, then I'm figuring out what to do with that stuff, and then I'm sending a response back again, which would happen down here, out to client, send write object with something. It would be a response object, I think. And that would be that. But as I said, I want to take this and split out into the request handler. So I'm just going to rename this one into request receiver according to the diagram. Request receiver, and then I have my request handler. So instead of this, I get a request handler here, request handler, and I assign it to a field, and we just say request handler.handle with the request object, and that returns an object, and then we create a response object, new response object with some kind of, I don't know, status, I guess, which is just a string and an object. The handle, which I call response, which is not a good idea, so I would call this response object. And this one would be written back again, and that can, yeah, okay. So I need a response object. Response object. Yeah, import that. And the status, as I said, is a string status success. Yeah. So I get something back, which means it's a success. And I wrap that into a response object, and then we send it back to the client again. But we might also get exceptions from down here, because my logic throws exceptions and the data access layer throws exceptions, in which case this is not a success. And let's do like this, status here, and response. Not entirely. So these two are defined. I need those. And let's wrap this in a try catch. So if everything succeeds in here, I just get my response and I get a status. And otherwise we say response payload Elon message and status error. So now on the client side, whenever it receives something back, it can check, is it a success or is it an error, in which case it can handle them in different ways and create that object and send it back again here. Alright, I think that's good enough for now. Point is that we have handed over responsibility of actually handling stuff to this request handler. So I shouldn't have to ever touch these two classes again, the request receiver and the socket server. This one, I will have to handle this one because it needs a request handler, and that request handler has to be created somewhere. So like this, request handler, and we initialize it through constructor. Okay, so I know there's a main method that will start this and create my request handler for me somewhere, and that's given to that request receiver, and then this works. Right. Read the incoming request, handle that request, well, no, hand over the responsibility of handling that, and then write a response back again. I mean, even if this handle method calls a void method on one of my user service, update username, maybe I'll just return null and say the response payload is null, so there's nothing to get. Okay, time's flying. So I have my upper socket layer working. My request handler is isolated, meaning that I can actually create other kinds of server variations. If you were to do a C# client, then you could not use the object streams, then you would have to send JSON as byte arrays. So I could create a different C# or byte array request receiver, but use the same request handler. So there's some potential future reusability in splitting it out like this. That's maybe okay. So what do we need to do? I have the handle. That's the one that doesn't do anything. So let's start here. User service, we need to assign that. Yeah. So I know for the create stuff, I have all the layers below, so I just need to make this one manage the create. So I get a request object, and here we say string request type, request object, and object payload, request object payload. The method I don't have yet, create method, payload. Okay, and then we say switch request type, and now I might do like this case user slash, because that's what this is the protocol I define. I want to do something with the user. What do I want to do? Well, I want to update username. Right, I need to do something. Break. Obviously, I will fix this at some point. All case task slash update remaining estimate. Right, that's something we can do, and so on. So this switch statement is going to be pretty long when I start everything with I can do with the user and everything I do with tasks and everything I can do with projects and subtasks, and those are the 4 I created. Maybe I want to involve sprints as well if it's a Scrum framework or whatever. So I'm going to split the responsibility a little bit and say string prefix request type dot split on this, and I want the first one 0 and string action request type. Do I need to split twice? Probably not, but like this. Okay, and then we can say switch, no, sorry, case, and I want to instead do it on the action, no, on the prefix, right? And if the prefix is user, we say handle handle user actions with the action and the payload. Right, so this is the user and this is the create or update, and then we say break. Oh, I returned, so I don't need that. And case task return handle task actions with the action and the payload. So now I can create different methods that will be handled by, they will handle different entities. So it's a bit more split out. If I get to this point, throw new, I should create a custom exception, but what do we call these? Handler prefix not found. So if I were to make a request from the user called sprint / do something, right, then I will not find anything to handle sprints, or if I misspelled something, do something. Okay, so that will just say I could not figure out what you wanted to do. Okay, so let's create these methods. This one, handle actions, will not do anything, task actions, but this one, just move it up. In here we want to do the actual commands or actions. This is, this will be the update user name, update password, and so on, or create. So we say switch on the action and the yes, can throw new runtime exception action not recognized. So if you try to tell the server to do something it doesn't know about, then we'll throw an exception, and we can return that because it's handled by the request receiver, right? Where you get that. So if the case is create, that's the first one. We say user service create, and what do I give it? I give it the payload. Then no. Then I know that in the payload there is a string username. No, I know. What do I know? I know the payload will be a create user request. Okay, and then we can say username first, get username, because I should have that in here. String username, right? We have that. I also need a getter, create getter, yeah. And it needs a get, what? Oh, that's, okay. So this is record style getters or accessors, and this is bean styles accessors, and this is what you will see in most of Java, and this is what you will see a few other places. I personally prefer this, but so that's why I have my IntelliJ set to create that as a default, but just to keep it as you're familiar with, we call it get password. Okay, and this one actually returns a UID, so we can just say return that. And maybe that's it. No, let's go. Compiling. All right. So, and I am pretty confident that if the client is set up to send me a request object containing a payload of type create user request, then that now works. I have my test to prove that from the request handler point of view. Now let's just check the database, because I actually have multiple users in here, and obviously that's because I have this one left to do. So I can clear out, just close this, and clear out the table again, remove all the users, and I have that here. And what does it do? It says clear database, so this is the stuff, and I could just delete that, but then I know that I'm probably going to need it in other tests, so I am going to do a, here, let's put it here, Java class database test util, and public static void clear user table, and I take this, put in here, yeah, and okay, so this method I do need that get connection, but I can just do here. That's to the test database. So maybe I will instead what will I do? We'll see if this works. This one has to be static. Okay, so now this one works, and this one has a related problem. Maybe, why? Get connection, and I could import static, or we can do, just to make it clear, database util get connection. Okay, so I'm not entirely sure when I have to register this. It probably should be just once, and then it's okay, but during the lifetime of things, okay. So let's just say database database test util clear user table, okay, and I can do it over here, clear user table. It's okay to throw that. So I have the same code, right? It does the same thing, and if I ever need to clear user table somewhere else, I can do that with this centralized method. And okay, so I still have to modify this string multiple places, so I could put that into the database test util as well, because I have it over here as well, for example. Okay, so I want to refactor that too, and say database test util and pg0i, and it's going to be a constant field of type string, like that, yes, and public static final string username Postgres, and public static final string password, and what was that? Database. So again, centralized one place, we say this one, username, password, and this one, user DAO, we'll just override it over here. So a bunch of refactoring, probably more than I should before actually testing things, but let's just run everything and see if it works. All green, wonderful. It does feel nice to have all these tests in place, so I can verify everything I change. I'm getting used to that. Okay, at some point I will also have a clear, just make it just so you can see again, because static void clear task table, I'm going to need it, throws, SQL exception, yeah, whatever. And quick and dirty, I don't feel like I should be, this should be needed all the time, but I really don't. A newly loaded RAM class should call the method. Currently, okay, so it doesn't matter if I do it more times, I just need to do it at least as many times as is necessary. Okay, so these does the same thing. Right? The only change is just the argument. So yeah, replace, and we give it an argument of type user and type task, and we want to add a string table like that, and here we say, how do we do this in a nice clean way? Like this, like that. Okay, just to be sure, see what I broke. Surprisingly little. So that's neat. Now I have the clear task table, clear user table, so if I need this eventually, but I can see that's going to be in the next video. Let's just do a failure scenario. So test public void should fail creating user given invalid password. And the request type is the same, and that's the same, and the payload is the same. So the arrange, but the password should now not contain a symbol, so that will fail. And then we say the act is going to be, and the assert is going to be the same combined, right? Because I expect to get a domain logic exception. So yeah, assert throws domain logic exception. That's what we expect to get, and that happens when we call the request handler dot handle with my request object. Okay. Let's see. Also seems to work. I get my thrown exception. So let's just do one more thing here. Test public void should update username. And what do? We say arrange. This time around string request type is user update username, and the request payload would be update username request. That's the payload, yeah. New update username request with a, what do I need for this? I need a user service. I need just to give it the ID and the username, the new username, right? So I need an ID. String ID is equal to UID dot this one, and I need a, I also need the existing username. Existing username, that's going to just be username. And well, I also need to say create user with ID, existing username, and a password. So that puts it in to the database, and then we can create a request. Let's call this the acting part. And this one takes the ID and it takes the new username. So we just say updated username like that, and we create a request object, new request object with the request type, just put down here, and the payload. And then we say request handler, handle request object, assert. What do? We say data access object find with the ID that returns to me a user, and then we say assert equals existing username. That's the initial. No, I want this one here. Let's call it actual or expected, right? Expected. Now I have to go and rename all my other actual variables. Expected username compared to the actual username, that's this one. All right. So first create the user, then make the request and actually send that request to the handler, then verify it went all the way through the system and we get the updated username. So I need a username request like this, like that. It's serializable like that. And what do I need to give it? I need to give it stuff, ID and a string, ID and new username. And we need variables for this. Yeah, and I need getters. I see I have record style, but let's just do it in default to be consistent, like that. So my test compiles. Create the user, create the request, hand over the request, verify that everything was handled correctly. Let's go. Obviously it fails because my handle probably throws a action update username not recognized. Right. So let's go and fix this. And here, handle user and user actions, case, update username. What do? We say it is an update username request. update username request of the payload, and user service update username, and we say your get ID, your get new username. And we don't have anything to return from this one. Returns void, so I just return null here. I always have to return something. So maybe I want to do something else and say case default, or default, yeah. So if I don't match any of the cases, we will throw this. But if I do match a case here, but don't have anything to return, we will eventually here down just return null. That's because I need a break instead. I don't know if that's better then. I'll put it here, return null. Okay, so that's my handler. Should be enough. I have added a new case. It just hands over the responsibility to the user service. Let's go again. It works. Let's just do all of them. I have 3. I have a failure there. Yes. Pretty neat. So I think that's I should do a failure case for this also, but it's going to be pretty much similar to this one. We just get a domain exception, so that's not really interesting to show in the video. So I made my system. I split the server stuff into 2 parts, the one that actually handles the request and the one that manages sockets and threads here. So splitting responsibility makes it easier to test things. And making code that is testable often improves your design, so that's a nice correlation. And I have that I can test my entire system. This way I can implement all my features through tests, and then at some point I will make a client that can also connect to this one. So that's very convenient, and that took a long time, so I think I'll just stop here and then say in the next video I will do a next one, because I want to show you the entire cohesive implementation. We will just do the create task in this one in the next video. Then I'm probably done, unless I figure out something else I want to do, because initially I just planned the 3 videos, introduction to basic server architecture, but it's been a lot more focused on testing lately, so at some point my path diverted from the plan, or my destination was reached and I just went further. So, but this has been fun at least, so I've had good time and learned something. So I have 1 video left at least. Maybe I will figure out other stuff that I want to do, but for now, thank you for watching.